Okay, welcome back. What we want to do now is to look at two applications of the VAR. So if you can go to, in the lecture material, in the vector autoregression folder, folder 8, you will find the practical example of Stock and Watson, which is simply an article, and I want you to perhaps open the Stock Watson key work file there, and maybe on the side, if you want, the practical illustration document. It's the one that I have open here, and the work file is the one that I have open here in the back. And then, so folder 8, go to practical example, the Stock and Watson paper of 2001. The paper is also there. And then there's another example here, the paper published in last year. So we will look at that as well as the Stock and Watson paper. We will replicate what is done there. Oh, now I've closed my drive. So just as an example, maybe I must just open the Stock and Watson paper quickly as well. So since the data comes with it, it is a nice application to use. Some general economic theory, Phillips curve behind this. Okay, so what we have here is the data that was available together with the paper. And increasingly these days, results being reproducible, many journals, if we submit to the journal, it already asks us to submit at least give a link to the repository where the data is with the code, if you've written some MATLAB programs or whatever. So you have to upload so that another researcher can replicate your results. And the good thing of that is that the more people that use your code will cite your work, and then that's how people that have so many citations, that's one way of being recognized in your field. Okay, so the labeling of the variables, I didn't change it from what it is in the paper. The FYFF variable is just the federal funds rate, the policy rate. And then the GDPD is the implicit deflator of the GDP. So the choice here, why working with the full GDP basket as opposed to the consumer basket? That's always a choice. So if they use the implicit GDP deflator, so that is what's in that basket is obviously all the goods and services produced in the US economy over this period, rather than just a few goods in the consumption basket. And then the unemployment rate of all workers 16 years and over. So the first thing here is to just generate the inflation from that implicit deflator. So we can already see that I've already done it there. If we just look at the graph of the implicit deflator, it will typically show typically it's sometimes it's an exponential trend. Here we can see with the oil price shocks a sharper increase in the price level and then a slowdown in that increase again. So that will reflect in the inflation rate as well. So and we just calculated that as the difference of the log times 100 to give us this quarterly inflation rate. Like that. What is also often done is that the inflation rate is calculated on the same quarter of the previous year or the same month of the previous year, depending on, so there are different approaches to do that. Sometimes it's just simply quarter on, this will be a quarter on quarter rate of inflation. So you have the choice there as well. And then the unemployment rate. So the three variables that we have, if we look at that, again, it may be questionable whether that series is stationary. Yes.
On we see the general practice where it went into the difference of the number of
No, it's not. You have a choice. It's the normal way. If it's a just annual data, yes, that will be how we do it. But that is approximately equal, that equal sign that's curvy to the calculation GDP minus GDP minus 1 over GDP minus 1 times 100. Because of log scale, each time you double on the log scale, every unit is a doubling. So it's the growth rate. So however you calculate this, this is kind of the standard way. I'm just wondering, I see so many of my colleagues using high frequency data. They just do a quarter on quarter, while we actually know the right way would be quarter on same quarter as the previous year. So that's a different. If you doing this research, I would definitely compare those different calculations or just use published inflation data, whatever was the official data. This actually just crossed my mind now that this might not be the best calculation. I think I followed what was done in the paper. So if we perform unitary tests, and this is one of those occasions that you can see, this is just the quick way, the quick dirty way, run the unitary test for the intercept model. And inflation and unemployment appears to be stationary, but the federal funds rate, that one, is not stationary. It's outside that 10% critical value. However, if we perform a unitary test allowing for a break, so if we can just go there and go to the federal funds rate and perform that unitary test, but not the standard unitary test, the breakpoint unitary test. Here you have different options. You can make the assumption that the break is an intercept break or a trend break. You can choose between innovative outlier or additive outlier, where that is it a sudden break or a gradual change? And here you have different options, of which you can also specify a user-defined break. In this case, I just use the defaults, and if we use that, and now my font is quite large, maybe I must just to show this. We see that when we allow, when we perform a unitary test allowing for a structural break, that it then picks up a break around 1980, and then it is stationary at the 10% level. So this is a way to justify using that as the federal funds rate as a plug it into the VAR, as opposed to differencing, which will be preferred, because if we only difference the federal funds rate and keep the other variables in levels, it's a little bit, will we get the results that we expect? Because now it's a change in the change of the interest rate. It's not that innovation in the policy rate from 4% to 4, something%. And that's the way Stock and Watson also use it in their paper. So now we want to set up our VAR. If we think about policy rate, inflation, unemployment, which of those will be most exogenous?
Policy.
Sean says policy.
It's a point says unemployment and
Policy, inflation, unemployment. What is the first dog that goes? The policy rate, I would assume there's a body that supposedly acts independently, exogenously, even though they survey, there's always that subjective mind frame that we have to be cautionary. Yes, we see inflation going up, but maybe now it's not the good time because the growth is really we need more economic growth, unemployment is on the rise, so maybe we should not, this is not the right time to increase the policy rate. So that's the first point. And in terms of this, there are not those intermediate variables before we reach inflation. So the next stop would be inflation. And then, and if inflation goes down, that may create a conducive environment for unemployment also to go down. And the good thing of this, since this model is atheoretical, it's not a specification issue if we don't have all those intermediate variables in. if you can put them in, then the whole transmission effect can take nicely, can take effect, and we can observe that then. So now we want to define our VAR. So we have already decided that we will include 3 variables, so we need to decide how many lags. So in order to estimate that VAR, although it's here, let's do it all from scratch by selecting the most exogenous variable first. So the policy rate, then the inflation rate, and then the unemployment rate. And then we open as a VAR. And we can just it is okay for now. And we can see that we have 216 observations. That's quite a large number. And now we have one equation for the federal funds rate. If we read down, federal funds in period T is a function of federal funds in the previous and 2 periods back. It's a function of lagged inflation, and it is a function of lagged unemployment rate. And at the same time, all other the inflation equation is a function of lagged outcomes of those variables as well as the unemployment. So in order to understand, to get a feel of how many lags to include, we will do the lag length test. And since we have quarterly data, what would make sense? So we can go to the lag structure option and go to the lag length criteria. And then just allow for you see, it feels by itself what you need to do 8 lags. You can put it at 12 if you want, but then it might be that the akahiki may go above 8. And what are our choices? Some selection criteria suggest 6 and some suggest 2. So now there's not a textbook that can tell us what to do now. Now you have to decide, do I want a simpler, more parsimonious model, or do I want to have more detail and more accuracy at the risk of overfitting the model and have more noise than needed? But there's absolutely nothing prevent us from testing both and see what we get. The trends should be the same. I think the 6 will just maybe give more variation on that trend path. So what should we do next? Before we estimate the VAR, maybe just see that the inverse of all our roots are inside the unit circle. So if we go to the lag structure option again, and go to the AR roots graph, we see that the inverse of the roots are inside the circle. So the VAR is stable. This also thinks the series are stationary. Just to get a feel of what are causing what. We know in the most general sense, everything should be, obviously now at this point, based on what our lag selection test said, we can change the lag structure here. If you want to have 6 lags, you will change that to 1 space 6. So that will include 6 lags, 1 space 2 will include 2 lags. So this will still be a standard or reduced form VAR. Other options are a VEC-M, a Bayesian VAR, a switching VAR, mixed frequency VAR, a whole lot of options there. So on this now we can still the same lag structure submenu, we can just investigate the Granger causality or block exogeneity tests. The world is similar to an F test. And how do we read this? We see that, for instance, there are some rejections and some failure to reject. There's one table for each equation. And this is for the federal funds, right? So what do we see there? A change, if inflation is what we cannot say, there's no direction in there's no signs on the parameters. It only says a change in inflation will significantly, with a lag, affect the federal funds rate, meaning the Fed are doing their job. Probably, if the signs have got the right sign. That is just something that is important to keep in mind. Because sometimes, if you just do this, you have you do a test, you think climate changes, rising temperatures should affect productivity. And then you do a test and it appears that it affects productivity, but if you go and look at the sign, it was actually for that sector, higher temperatures was associated with higher productivity overall. So the story is more nuanced like that. So we cannot too easily jump to conclusions and say this was a good result. Also, that the fact that we see a rejection here, in other words, unemployment rate, a change in unemployment rate will result in a change in federal funds rate. And for the inflation, federal funds will affect inflation, but unemployment will not affect inflation, which makes sense. If people are not working, that can probably not be, I don't see a link to higher inflation. And then here, the federal funds will affect unemployment, hopefully in the right way. Lower rates can lower unemployment, and higher rates will result in higher unemployment. Because through the higher costs of production and firms have to lay off people through that transmission. And then higher inflation does not lead to, according to this, to higher unemployment. But higher interest rates do. So this is just already, before we do anything more, we have an idea of where we will see significant impulses. So there's a description of that interpretation and offer some explanation. So now the next step is we have this VAR, and if we now ask for impulse responses with the Kuleski decomposition, what will happen in the background is those identification system. Those 0 restrictions will be placed on the lower part of the lower triangle of the coefficient matrix. So if we go to view and we go to impulse responses, if you just click OK, obviously choose a horizon length, maybe 4 years, which will be it's quarterly. If we choose 36, it will be 9 years. For now, we don't need to change anything. Maybe we can, maybe we can select bootstrap standard percentile, and you can choose either between 95% or 90% intervals. Typically, we will work with 1,000 bootstrap replications. This is so close to 1,000, it doesn't really matter. So we can change a little bit here, and that's all that we need to do. Then we will see a picture of everything affecting everything else. And maybe I will just make this big. And you can imagine if you have 9 variables, then you will get a 9 by 9. We now have, you always have the option to limit the impulses or the responses. Just to zoom in a little bit. If we actually, maybe for a second, we're just interested to see how the policy rate actually affected all other variables, and not worry so much if unemployment goes up, what will happen to the other variables, or inflation goes up. Otherwise, you can just read it from here, but I find it difficult for the eye, if you have a 9 by 9, to search for which one is now the one where I can see what happens to unemployment if the federal fund is increased. But let's see how we read it. On the diagonal, it's just how the federal fund rates respond to changes in its own past. And typically on the diagonal, we will always see like kind of a very autoregressive pattern. So we're not so much interested in that one, and that one. Here is maybe one where we're interested, how does inflation respond to an innovation in the interest rate? And we can see it's small now, so we can make that bigger. But this is where we will look at how inflation will respond to federal funds. And here we will look at how unemployment will respond to a federal funds innovation. On this column, if inflation starts going up, will the Fed step in and counteract by raising the policy rate? And here, will higher inflation lead to higher unemployment? And in these higher unemployment, what will happen to the federal funds, or this or this? So maybe to make it easier to interpret, what we can do is firstly use the wizard here and just ask for untick the other variables so that we only can zoom in on the impact on the other variable, the inflation and the unemployment. I just want to see if I make that, if I change the 95 to 90, how much difference it makes. I suspect not a lot. So if we work with 90% confidence interval, we see a slightly larger portion of significance. Okay, so help me out here. How effective is monetary policy given this, I don't know, 200 and something observations way back? Way back. What do we see? What happens to inflation? How many periods? What happens in the beginning? Does it come down? Does it come down significantly?
It first rises.
There's first that price puzzle, then it starts coming down and it is significant up to like 6 or 7, I think that will be like 7 quarters. Then there's still indication that it's going down, but it's as if it's no longer a significant effect. How about unemployment? When the interest rate, if there's an innovation in the interest rate, that will cause unemployment to rise and quite for a long time, according to this analysis. And where it crosses the line, I know there's strictly, there's maybe that little period that strictly we can't say is it now significant or not, but the fact that it crosses the line and then is still significant, I would believe that unemployment rises significantly for 8 quarters, and that's not a magnitude. What we see here on these axes are not numbers that you can say this is so many dollars or so many percentage points, or we just interpret that in terms of the direction of trend and how long it lasts and is it significant. We have other tools to quantify those impacts.
Can you come again on the significance?
Yeah. So a variable is the impact is technically significant as long as you have to see where the area, these confidence intervals, where the lower or the upper one crosses the 0 line. So up to that point, we interpret that as a significant impact. And for this one, that is where the significance are no longer, where that impact is no longer significant. And here up to 20 periods, although after a while it's not, unemployment are not rising, there is then maybe other factors that bring it down.
Sorry, Prof. On the bottom graph, with the up to 5 then being insignificant because it's below the 0, the shadow part?
No.
Okay.
Just look at this part, okay. And for this part, both blue boundaries are on the same side.
Okay.
So they both on below 0 and they both are above. If you look here, both are above and then both, and here it's not significant because that line is above zero and this is below zero. So if we want to see, we can analyze it one by one. If we, for argument's sake, interested to know if inflation increases, if there's an innovation in inflation, how will the federal fund, the Fed respond? And it looks like higher inflation will prompt there to rise the federal funds rate. And in terms of unemployment, if the unemployment, oh no, we cannot say that. That we have to look at in the last one. But we can see that from a certain point onwards, higher inflation also leads to higher unemployment because of the negative impact on business. I have to select one before I can unselect another one. How about if there's any indication or some suggestion that the Fed will respond to rising unemployment? If unemployment is increasing, it seems that there's some room for the federal fund, the Fed to step in and lower interest rates. This is what we see here. At least that's the direction that the Fed will move in, because that will also probably mean that demand is low, growth is low, unemployment is up, and there's a need to stimulate the economy. And inflation will probably also be at that point lower, so they can lower the interest rate and stimulate the economy. So that's the principle. Yes.
Just a concern. So looking at
A concern. A confirm.
I haven't used this before, but looking at let's say the first graph,
Yeah.
the bottom values. They're speaking about the bottom values are for innovation.
These are the periods. Yeah, so this is after 5 quarters, after 10 quarters, after 36 quarters.
So in terms of the time period, right, or by reading innovation, we read it by going to the right to say when innovation increases.
No, we read it on this axis. Yes.
Then moving there, that's the response.
That's how long it will. Yes. So for the inflation, for the federal funds rate inflation response, that we see that other one that was in the lecture slides for this, that was an output of the global VAR, the South African VAR within the global VAR model. There was a price puzzle, and then after 8 quarters, the inflation was brought down to a significant level. Yeah. So just to reaffirm it for this one, how many quarters? So there's an innovation, and that innovation is set to one standard deviation of whatever the dependent variable is. So what is one standard deviation? You can work it out on the federal funds rate. It can be just so that we can compare apples with apples. So that one is not a large shock and the other one is a very tiny shock. So a one standard deviation innovation in the federal funds rate will bring inflation down, after a one-period price puzzle, and then it starts coming down, and it looks as if that downward trend remains significant up to 7 quarters or so. Then even though it continues further, it's at that point not statistically significant. So that's why it is important to have the confidence intervals around that. The other day a student came to show me his Bayesian VARs that he did, and he said he was still struggling to get the confidence intervals around using MATLAB. So we could not see if it was significant and for how many periods. So he was still working on his code to get that done. I have R code for this. I'm just still busy cleaning it up a little bit. But it's just learning the software. It's very easy to just see what we should look out for if we do our own coding. And at least if your R gives output, compare it with some other standard software like MATLAB or Stata or eViews or whatever. And that's it. I can maybe just, without doing the other exercise, I can just maybe say something about that a bigger exercise where we had more variables in the VAR based on this paper. So the idea that we investigated here was to just see, first as a reference point, analyze monetary policy with a number of variables using South African data dating back to the start of the inflation targeting period. Because obviously, if we go back all the way to the 70s, where we have the data, but then you actually have a structural change, a whole different policy. Before 2000, the target variable was money growth. We wanted to keep broad money within the bound 10 to 12%. So, although technically you can do it, and it actually shows quite good results, which mean that even though our official target was money growth, by containing money growth to 10 to 12% also contained inflation, with the exception, of course, of those oil price shocks and the impact of that. But say maybe we go back to like late 80s and use that data as well. So this paper, to investigate the uncertainty, we looked at uncertainty in the stock market, uncertainty in the currency market, uncertainty in the goods market, and global uncertainty. And if we bring that into the VAR, we wanted to see, is it now too hot? Huh? Too hot. Maybe I must just switch it off for a little bit. The thing with the air conditioning, it comes out in. So currency uncertainty, goods market uncertainty, stock market uncertainty, and global uncertainty. And what is the expectation? If there's more uncertainty, will monetary policy work as well as it would? Would it work better in more uncertain periods or in periods that are more stable and calm? When it's what? More stable and calm? No.
I think so. Depends on what's going on. But it's
Remember when there's so much uncertainty in the market, agents start behaving erratically, even the policy authority themselves then sometimes overreact. Too much too soon, or too little too late. And then we see that the effects do not work through as well. But I mean, that's the hypothesis. We're not sure, of course, at the outset. So in this paper, we go back to the beginning. Obviously, the two important variables are policy and inflation. And this trend that we have in the inflation, it looks like we had high inflation and suddenly it went to below zero. What happened there? Kuletso? Why is the official inflation rate? Did we go from 12% to negative inflation? The introduction was here. That was when they started to, when they removed the mortgage rates from the consumer basket, because they said it's not really fair that we penalize consumers for, if they raise the interest rate now, you pay more on your mortgage. That's not really fair, because that's something that you have no control over. You cannot say, I will now pay less. You can only change your behavior with other consumer goods and services. So when they did that recalculation, it obviously, when you take that out, now suddenly inflation looks much better. So it would have been nice if there was a backward, if they could have do that all the way back. But now we deal with this, but we know where that is coming from. So it wasn't really that the inflation was 12% and then minus 2%.
Sorry, Prof. So was the mortgage rate being quite a high weighting in that basket for it to have such a substantial impact?
Probably. Remember, how much of your salary goes towards your bond?
More than 100%.
No, then you live in a grand house. But it's a substantial percentage of our spending. So we threw everything in here under the kitchen sink, basically, all the monetary variables, in order to get following Pellegrino et al. to assess the impact of the policy changes. And you can see this is still the older software. The graphs are not so pretty, but this is the typical, not considering any uncertainty. So response of, obviously, money market rates will move together with the repo rate. Bonds will move together with that's the broad money. Broad money will be brought down. Response to, let's think about these two for a second. Higher interest rates are not so good for share prices. What's that? Yes, Kenny.
I'm guessing like it's more expensive for businesses to borrow, so they can't, I guess, invest.
So it's more expensive for businesses to borrow, which will then make their performance less well. That will lead to a decline in their share price values, dividends, whatever. But share price values. Also, there may be a move away because more money can be earned in the bond market, or the exchange rate, you can see not affected a little bit towards the end year, strengthening the exchange rate, but hardly. We can hardly say that is a significant impact. Investment is as a downward effect. Consumption, which we want to see, this is not a great thing, but that's a side effect of higher interest rates. This will cool the economy down through lower consumption, and
Sorry, Bob, I just wanted to ask, like for investment, like what do you mean by investment? Is this like investment in like
that is the gross fixed capital formation. So it's private investment, government investment, foreign direct investment. Inflation, this again the price puzzle, but bringing inflation down significantly for up to 12 quarters. Or is this monthly? This may be monthly. I just have to check. But we have the data. And then also higher interest rates, not great for output. The only limitation, I think this is monthly data. Industrial product, we don't have monthly GDP, so we often have to work with industrial production, which is the output of the manufacturing sector, but we don't have such a strong manufacturing sector. We're much better in services and to some extent also the primary sector. That's where our strength lies and our growth comes from. So this is always a limitation in the work that we do. For other countries, it may be less of a limitation. But then if we look at different measures of uncertainty, so what we do is, or in the literature that we follow, if you interact the uncertainty with the policy rate, and we tried it for every form of uncertainty. This one is the uncertainty for the stock market. We can see each time in the high uncertainty scenario, it's almost that there's nothing significant. These confidence bands remain to both sides of the zero line, whereas only in the low uncertainty periods we see better of effect, and some of them even better than other ones. If we think about uncertainty in the goods market, which is inflation uncertainty, then we see a response in both, but a better response in the low uncertainty period. And we also, I think in the assignment, we also tested global uncertainty, but I can maybe just quickly go to that low and high uncertainty periods so that we can see that so here we focused on those 9 variables, and you can see as soon as you work in monthly data, even though the series are already seasonally adjusted, there are still some of these, it's not a smooth line. So we replicated some of the things in there, but let's just look at, this is global uncertainty. Global economic policy uncertainty from the Baker and Bloom study. I mean, they have a website and there's a whole lot of different uncertainties that you can download there. But where's the biggest periods of uncertainty globally? Obviously COVID, and an extended still, it shows up globally. It's still, maybe it's new factors as well, but it's not a lingering effect of COVID, but the whole world is a little bit crazy currently. Around the global financial crisis, what was this 9/11 and things that happened around here. What was the big deal here again? I know there was some quantitative easing and, but what was the, yeah, so we, do you know, Tombi? Yeah, it's, so that would be something to investigate a little bit, but what is insightful to me is that what is driving that as well. But there's also these different financial stress indices, which is basically measuring stock market uncertainty, first and second moment, and bond differentials and all of that. So it's interesting to investigate the impact of all these different uncertainties on our outcomes. Okay, so that is the VAR. And if you go Bayesian VAR, if you go structural VAR, eventually we still look at these impulse responses. Basically the same effect, same idea. Any other comment, question? The next thing we have to do is the VEC-M. Yes.
I'm going to ask, based on the results that we got, we use stationary data.
Yes.
So, when we use stationary data, what is the results? Are they for the short run and still need to go to
they effectively short run results. Yes. What was the other thing I wanted to say here? Yes, we still have to think of what we have. But as I said, you now also see papers that do these things in levels. The Pellegrino, in that paper we used levels. The Pellegrino, because Pellegrino used, it all used levels. And when I looked at Lesego's Bayesian VAR, he was looking for an increase in income. But then I said, but remember, you don't have income, it's actually economic growth. So he wanted to see income increase, but growth would not show a linear trend, it will show something like that. So yeah, we still have to think about what we do there. But good question. I think in the next set of slides we will see that story of what if I don't find co-integration, should I difference and run a VAR, or what should I do? The textbooks sometimes say difference and run a VAR. Yes.
Just on the topic of Bayesian bars, right? When you do your holistic ordering of the variables, you touched on this earlier when we were talking about
The generalized.
what
In the generalized impulse responses, we don't need to order.
yeah, okay, yes. But when you're building a VAR, you need a certain order.
Yes.
Okay, this is my most exogenous variable, so slow moving to fast moving, right? Or in terms of the shock in the system.
Yes.
So we mentioned earlier when you were talking about, because this is something I've been thinking about when looking at mining sector,
Mm-hmm.
right? Looking at mining GDA and trying to forecast where that is going. What comes first, volumes of electricity produced or volumes of mining mining production?
Yes, good question. That's exactly some of those hypotheses that people test, and the hypotheses actually have names. I forgot now what they are, but what goes first, production or electricity? Do you need to up electricity so that you can produce more, or do the economy first need to produce more so that we can expand and produce more electricity? I think in this specific case, I have a feeling that electricity goes first and then production, if you only think about mining production and electricity. But I mean, running then those block exogeneity tests will give you a little bit of a feeling, and then test both. I feel that there's maybe a very tight bidirectional causality there.
Because I was thinking, looking at the FEBDs in the end to see if the contribution to overall, which one contributes more.
Yes. Yes.
Okay.
Yeah, perhaps try some of those block exogeneity tests, and if you can even try some of the time varying causality, then you can see over time during which periods maybe there's also shifts in that relationship. There may be periods that electricity production actually did lag and hold back mining, and then other periods when maybe historically when we produced much more that could help mining production. Yeah, just look at it from through a prism, very many angles at the relationship. Yeah, it's interesting. So this topic relates back to what we did with the Engel-Granger, but what's the added benefit? Why would you choose Johansen over Engel-Granger? Or consider using that?
I think it's because this one makes us ecosystem.
If you have 5 variables, and though there are prices and wages and production, there can be more than one relationship going on there. Especially if we know from economic theory that we want to model prices and wages simultaneously, and labor market effects. Then that will be a good procedure to consider. Also, it links to the VAR methodology, or it links back from this methodology to the VAR methodology. We read in the textbooks, if you have a number of variables and you test for co-integration and you don't find it, the textbook says difference and run a VAR. But I want to add a caution there. Don't immediately do that. Just try a little bit and see if you don't, because running a VAR in differences, you lose economic information. The reason why we do it in this order is that literally the ingredients of the multivariate co-integration is a standard reduced form VAR. So it relies on the fact that the principle, the Sims principle, that everything can cause everything else, it relies on the fact that dynamics matter, and we start very general and we rely on maths, and that generalization, and maybe still arrive at exactly the same destination. If we test 4 variables for co-integration, how many relationships can there potentially be? 3. If we have n variables, there can potentially be n minus 1 linearly independent relationships. If we have 3, if we have money as a function of income and interest rates, it can be possible that the test will tell us there's 2 linear relationships there. Because this is mathematics, and those calculations of the rank of the pi matrix doesn't have that AI training to know that that it may find 2 independent relationships, but the other one can just simply be because money and income moves closely together. So that can be the second relationship. So that's what we want to do. And then now we have to do that action of imposing restrictions. Now we have to use economic theories, similar to a structural VAR, we have to use economic theory to impose these restrictions so that we can extract the economic relationships there. And I know this is now again a case, like you told me after the VAR technical lecture, that maybe if you can see the application first, then this all will make sense. So it's a chicken egg situation. We will go through the math first and then see the application, but sometimes it's good to see the application first and then the math. So the Engel-Granger approach, obviously, it's so easy it's so intuitive, but it serves as but while the other methods are more complicated, it serves as a very easy reference point. The limitation is, however, that only when there's one co-integrating vector can we claim that we have consistent estimates. So this is an example that we've seen before, and we said that if we can test the existence of co-integration between these three series, then we will claim these will be our long run steady state parameters. So on average, if the GDP expands by 1 unit, the demand, by 1%, the demand for broad money to facilitate all these transactions and speculation and everything that goes on will be almost 1.76%, whereas the impact of the higher interest rates will lower demand for money by almost 3%, by 100 basis points increase in the interest rate. If we perform that test, we see here in this application for this period from 66 to 2017, I think in a later example where we updated that way to the last, we did see that this probability was a little bit higher. So we built the ECM, and in its simplest form, an ECM can look like that. We can bring in other factors like business confidence or things like that to try and pick up the turning points, but in its very simplest form, that will be an error correction model, where this measures the speed of adjustment, and these are my long-run parameters. And when we go to a VEC-M now, and then we'll have more than one equation. There can now also be an interest rate equation. We can endogenize interest rates. So there will be a second equation. The second equation will also have a speed of adjustment parameter. So that then creates a matrix, which we will call the loading matrix, where all those speed of adjustment parameters will live. We will have, here we have just a vector of betas. Every time we add another equation here, we add another row to the beta parameter matrix. So instead of calling it the speed of adjustment, we refer to those speed of adjustment parameters the loading matrix. And then the betas are still our matrix of long-run parameters. The question is, this I have obtained with the two-step Engel-Granger procedure. What if I present the multivariate Johansen process with the same result? With this data, what long-run parameters will it come up with? Do you think a similar result or a different result? It will not be similar to the last digit, but it's not that the Johansen will ever give us 4.6 or something. Let's just keep this in mind, minus 1.76. And remember, this is now on the same side of the equal sign, so the coefficient is actually plus 1.76, and this is minus 0.03. But if I go all the way to the end, I think in this slide, we go there, 1.745, 1.75, 0.03. So very similar, very similar, very similar. So, and this is what we want. That is the idea. If we indeed have a unique co-integrating vector, the different methods should give us a very similar result. even though the methods are vastly, this is a maximum likelihood estimation, the rank test is using eigenvalues and eigenvectors of the pi matrix, etc., etc. So it is literally like taking two routes on your navigation app to Johannesburg CBD or whatever. Some days it will be quicker this way, some days it will be quicker that way. So the limitations, as we've said, just to remind ourselves that in the case of Engel, the idea is if you have Y and Z and they co-move, if we want to claim they co-integrate, it should, strictly speaking, whether we put the Y on the left and Z on the left based on the Sims idea, we should get exactly the same result, asymptotically. However, in this case, it's not so different, if we look at consumption and income, because we don't even have a very large sample here, but they're very close. But look at this. If we put interest rates, if we look at these three variables, it's the capital market rate, this can be, I think, the 10-year bond rate or whatever, and then the repo, which represents the monetary policy, and the debt GDP, which is a crude measure of the fiscal stance. We can see that in this case, we see co-integration, but not in this case. And in the Engel-Granger, if we're interested to model interest rates, we will only look at this. We will ignore the rest, but this is the problem then with the Engel-Granger framework. So though these are some of the references. And some of these early papers also applied it to money, but to money, the UK broad money supply. So multivariate co-integration, and you will see there are now a few other steps, but we will first, it will involve testing for co-integration. That maybe comes a little bit later. We test for the VAR, we estimate the VAR, and then we just decide, do we want to include a constant in the long run, in the short run? For Engel-Granger, we have kept a constant both the long run and the short run. We can include trends in both of that, if that's applicable. And then we will also testing for reduced rank. That is, how many co-integrating vectors do we find in simple language? So we have the option to actually, these deterministic trends, intercepts and trends, they are similar to using unitary test, they matter. So we will have to think which are most appropriate when we do the tests. So all of that is simply what we said already. We are going to look for unique vectors in that alpha, beta, or the pi matrix, and we will end up placing restrictions to get the theory from there. It starts with the VAR model, and we wrote it here as matrix notation, so this is now fresh in our minds, the Sims idea of the reduced form VAR, and we regress lags of all the variables on each variable, and we want to find that trade-off, not too many lags and not too few lags. A little bit like Goldilocks' porridge, not too hot, not too cold, just right. So let's not repeat that. This is now, if you look at this is now the VEC M. And we can now recognize those ingredients the same as we recognize it for the ECM. Differences, if, and this Z will now be a vector of, say, 3 variables. Z will be money, income, interest rates, and those 3 will be included in levels in the long run. In that Z in levels, there's no difference there. And here we have the dynamics, and here we model the vector error correction model in differences. So there's short run adjustments here and long run that pi is now my long run coefficients. Pi is equal to alpha beta prime, and alpha are the speed of adjustment, beta are our, and this is still where our interest lies. It's still about those betas. So in that matrix, if we have n variables, that dimension will be n by n, and we are looking inside there for n minus 1 co-integrating relationships. Money, income, interest rates, do we find 1, or is that second one money and income? Just the statistical relationship, more or less. So now you will note something that doesn't look right, maybe. If I write this out in general, do I get this, or is there something missing? Here's only 2 columns, and here we have 2 rows. So the third column is there and the third row is here, but we have already restricted them to 0. Because 3 co-integrating vectors with 3 speeds of adjustment, that's not relevant, because that will mean we have 3 co-integrating vectors in a system of 3 variables, and that's clearly an implication that we're actually working with stationary data. That's the only place where they will all move in the same direction. Just in compact matrix notation, that pi is equal to the alpha beta prime. And you can see a lot of that matrix down up here translates to 3 equations in first difference form. This is money, income, interest rates. Potentially I can have 2 long run relationships. You can see level, 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 different betas in front, different speed of adjustments. And then you can decide, typically what we do is we put both long runs in every error correction model, or maybe we omit and we only keep money's long run in the money equation, depending on the exogeneity assumptions that we make. So all of this look very messy, but when we apply it, then it's like quite clear.
Yes.
that's just zooming in on that little bit to give this idea of reduced rank. For 3 variables, we're only going to consider 2 equations, and then of course we will have to place restrictions here. We cannot have every variable being a function of all the other variables. That will not be identified, so we will not be able to solve that system or even estimate those parameters. And these are the 2 long runs for all. It's just breaking up that long equation into different bits. Oh, how have I done? Oh, I've discovered the function. If you want to hide something, you just keep this button in. If you see a mistake, like my 10,000 emails. So example, if for three variables, we would like to see R equals to 1 or 2. 0 will be a problem, 3 will be a problem. So we want to see reduced rank, but ideally not 0, because that will mean no co-integration, which means back to the drawing board or difference and run a VAR. So that's the options there. So what else? So assuming that we have non-stationary data, so if we have stationary data, if you catch yourself going through all of this pain with stationary data, that's a waste of good time. Because what are we doing? Assuming that we have non-stationary data, it will involve estimating a number of error correction models, while when we have stationary data, we can just run a normal. If we deal with non-stationary data, stationary data, we can just run a standard Sims VAR. When we test for the rank and we find that R is 0, that means we now don't have any co-integration. This is the textbook solution. Estimate the VAR in first differences, no long run exists. All that I say is just try a little bit harder before you move there. Like if you test money and you get that co-integration p-value 0.02, 0.12, remember for the money we just had to control for the financial crisis and the p-value came down to 0.02. We kind of know, based on economic theory, there must be a simple money demand equation. So going ahead and difference the data, you kind of ignore the economic theory. So just try a little bit harder, but if it's with difficult variables, it's climate and agricultural output and things that we're not so sure exactly what are the theoretical relationship here. Maybe it's not a strong economic theoretical relationship, then it's perfectly fine, I think, to go there. But this is where we want to be. We have n variables, and then we find up to n minus 2. So if we have 3 variables, we want to find 1 or 2. Not 0, then we're here. And if we find 3, then we're likely there. But then just check. Sometimes just because of small samples, you present your 3 series and it tells you you have 3 co-integrating vectors. And we know this, the data is not stationary. It's more a question of low quality data, short sample, so the power of the test. A lot of words. So we want the rank of the pi matrix to be smaller or equal to just 1 minus the number of variables. In mathematical terms, what we are looking for are linearly independent combinations of variables in that pi matrix. And what does that mean? I actually have just an Excel file here with what do we mean by linearly independent. So there are different definitions of when we can say we have, let me just go maybe here, or yeah. So if we look at this matrix D here, we have a column with 1, minus 2, 3, and here we have a column 0, minus 3, 3. So those two are independent, but the third column is actually the difference between the two. Or sometimes one is a multiple of the other. In this case, here we have just one, the columns are linearly independent. They are, oh, this one is actually minus 1 times the other one. So there's only one that's linearly independent, the other one is not. So the rank of this matrix is 1, the rank of this matrix is 2. So that's the one definition. The other definition is you look for this, for a determinant that is non-zero. And if we calculate the determinant of A here, we see that that determinant is 0. But if we calculate then the determinant of just that submatrix here, of those 4, it is non-zero. So that's what we're mathematically looking at, or even this method of which they teach you in the linear programming class, I think, where you have to find, you have to go through a few steps and see when one of the rows in that matrix, how many rows you can get equal to 0. Or, yes, I just put it into some kind of a toolkit to arrive at the same result. So this is what happens inside that to help us decide what is that, how many vectors are there. So can you see when Katerina came with the problem, said, I'm looking at money, I'm not sure if there's more things going on here. Soren said, light bulb, I know how you can do it. You have to find that lower echelon, see how many 0 rows you have in that pi matrix. For me still, I can see the math, but it's still difficult, or not really. You know, if you can see 2 columns are independent, a third is just a multiple of the third one, then you can claim two vectors there. But you can see it's much less intuitive than the Engel-Granger method. But do we have to calculate this ourselves? We just have to kind of have the intuition of how to understand that through the formal tests. And we have two tests. We have the trace test and the maximum eigenvalue test. How they are different, the trace test, the null will be no co-integration, 0 independent vectors against the alternative. And you can see this one is now more general, more than 0. Whereas the maximum eigenvalue test will have a sharper alternative, 0 against 1. And then 1 against 2, and then 2 against 3, until you reach the value of n. This one will each time test 0 against 1, 0 against 1, 2, 3, 2 against 2, 3, and then that's the end. So in the output, it looks like this. We test for co-integration between those 3 variables. The null is no co-integrating vectors against the alternative of more than 1. That is the trace statistic based on the eigenvalue of the pi matrix. It is bigger than the 5%. That's the probability. So it exceeds that 5% critical value. So we reject it at this case, the 1% level, but it will tell us here we have 1 at the 5% level. We can see it's borderline. It picks up that second money and income. That's at the 10%. There is a second one. And same with the maximum eigenvalue test. We have 1 at the actual 1% and not 5%, but the second one is at the 10%. Who is yawning? Is it that bad? Yes. Just a little bit of more information about those likelihood ratio tests, the statistics, the trace stat, and the maximum eigenvalue stat, how we calculate them. You can see once again, just like the model selection criteria, they use the same ingredients, the log likelihood, the number of parameters, etc. I know. The question is, if they don't tell me the same story, which test must I believe? Because you test and now you need to write your paper and you have to put the table there, which shows conflicting results. Which you actually obviously want to go with the result that you prefer, but how do you package your motivation? The maximum eigenvalue test have a sharper alternative. So that is sometimes preferable, but the trace statistic is generally considered to be more consistent. So I think where's that information? I took this from the manual. Oh, I think it's on the next slide. So the maximum eigenvalue has the sharper alternative, whereas the trace statistic leads to a more consistent procedure. So indeed, if you read papers, you see where it is applied preference is given to the trace stat in case of conflicting results, but obviously consider the underlying economic relationships from an economic theoretical perspective as well. And this is still version 13 of the software. Version 14, you will get 2 options here and 2 options here, but it is literally just giving more options on where do I want to put constants in the relationship. So now it is 5 different models of deterministics. Which one to use? A good guess. Let's think about them, and I'm going to tell you we can already scratch out 1 and 5, because why? Look how limiting this is. There's no intercept or trend in the CE stands for long run co-integrating relationship, and the test VAR means like in the ECM, in the short run part of the model. But so that's not good practice to have a constant anyway. And secondly, that assumes that the data will have zero means. It doesn't allow for data with a non-zero mean. So that one is very restrictive. I don't know for which discipline that will work. This one assumes quadratic trends in the data. So firstly, I2 trends in your data and a trend in your relationship. So in the model, you put a trend as one of the variables. So by that fact is less likely for the type of work that we do. Number 4 may be applicable occasionally, because that has a trend in the long run. If you model production and you want to put a trend as to represent or approximate technology, that will be 4. Otherwise, we search for solutions between 2 and 3. And the main difference between them is in terms of the assumption with the data. You can see 2 assumes only a stochastic trend in the data, no deterministic trend. So none of that gamma t on the right-hand side of the data generating process. Whereas here we assume stochastic trend plus a deterministic trend. I think a stochastic trend is always implicitly in a variable measuring human behavior. So, yes, that one allows for potentially a deterministic trend over and above a stochastic trend. It has a constant in the short run and the long run. That's why that button is on here. So we will see in the current version, they added just an additional option here and additional option here, just based on further papers by Johansson and others. The reference is there also, but the rank of the test don't change accordingly. but maybe you can get slightly better or weaker results by, instead of choosing, you will see there it's 3A and 3B, so choose, just test both and see what you get. This is just from the manual, which you can see sometimes if we read this in the published papers, you have to stretch your brain a little bit. It's just helpful if it's some English words. I've taken this from the Asteria and Hall chapter, the interpretation of exactly what we said now, but it's basically there in the menu. So as we said, model 1, unrealistic. Series hardly have zero means, and it's really bad econometric practice to have no constant anywhere in your model. And then 5 is unrealistic, implausible to have quadratic trends in the long run and linear trends in the short run. So a quadratic trend in your long run, I don't know, that's going to Mars or someplace, having that growth rates, I don't know. But we search for the best model fit between these, with these deterministic assumptions, and model 4 if we had a trend variable in the long run. Oh. Okay, why didn't anybody say something?
We're having so much fun, Prof.
So when we come back, this is now the applied part, and then we can actually apply it alongside, just almost through, and then we can apply it. So let's take an hour. So let's come back at 1:45.